revision, which is research methodology 2. And I remain Adegoke Juliet Ifeoluwa. I've been your online tutor for this course since first semester, where we had NSC 407. That is the introduction to research methodology 1. And this is the concluding part. I personally took you the face-to-face facilitation during the first semester. And I was able to discuss the nitty-gritty of research proposal, which is chapter 1 to chapter 3. Now we will discuss how you can achieve a good research, because it is expected of you that when you come for next session, which is 500 level first semester, you should be able to come with your research proposal, which is chapter 1 to 3. And there are some things that will help you to write a good research proposal. So that is the essence of what we want to discuss today. During the online facilitation, we discussed about 9 study sessions, starting with experimental research design. We also talked about data collection instruments, where we discussed observation. We also discussed questionnaires, interviews. We now move ahead to discuss research question. We also discussed research hypothesis testing, sample size determinations, and scales of measurement. I will have to take you back to what is research before we start discussing. What is research? Research is not a new word to you. So research means to search again, or it means to examine carefully. More specifically, you can define research according to Burns and Groove in 2005. He was able to define research as a diligent, systematic inquiry or investigation, either to validate and refine existing knowledge or to generate new knowledge. That is research for you. You carry out research either to validate existing knowledge or you generate new knowledge. And that will take us to research design. We have different types of research. We have experimental, non-experimental design. But the first one we discuss is experimental research design. When you hear the word experimental research, what should come to your mind is an experiment. I will take you back to, let's say you go to the lab, you want to carry out an experiment. So experimental research design is a scientific investigation in which an investigator manipulates and control. The word manipulate and control is bold because you have to carry out manipulation and also have control over what you are doing. So you control one or more independent variable and observe the dependent variable for variation concomitant to the manipulation of independent variable. I'm saying variable. Independent variable and dependent variable. What is the meaning? Independent variable is in a research study. What you can manipulate, what you have control over is the independent variable. Meanwhile, you observe the effect on the dependent variable. For example, this virtual learning class is a new innovation that we have started, that we embarked upon in ODL. This Zoom session is the independent variable that we have manipulations and control over. Then we now observe what will be the outcome on students' performance. That's what we observe the effect on the dependent variable. There are 2 most important conditions necessary for true experimental design, and they are randomization and control over independent variables. Before you select your research participant, especially in experimental work, you have to select your participants randomly. You remember in first semester, we discussed about population and samples. You have to select your samples using simple randomization, which makes them to have equal right of being participants of that research work. Also, you should have control over the independent variables. So 2 groups are important, the control group and the treatment group. The research design itself is just like a framework of research methods and techniques, which is chosen by the researcher. It can be said to be a blueprint for data collection, for measurement, and for analysis of your research work. Now, we have been mentioning variables. What is a variable? A variable is a qualitative or quantitative entity that can take on different values or levels. A variable can be a measurable trait which can change over the course of a research. It is any characteristics that can be measured or counted. Examples of variables include age, gender, which is sex, either male or female. Variable used in experimental research can be independent and dependent variables. So we have different types of variables that we use in experimental research work. We can have independent variable, we can have dependent variables. We can also have continuous variables, we can have discrete variables. We can have intervening variables and extraneous variables. I would like to explain what I mean by all these variables. The independent variable, can you hear me, please? Can you hear me? If you can hear me, say yes.
Please continue. They can hear you.
Your tight icon and type yes. Okay. Okay, good. I will have to explain all these types of variables. The first one is independent variable. I've talked about it just right now. There are those variables that the researcher has control over. For example, like I've said earlier, that the introduction of Zoom to replace the normal face-to-face facilitation is an example of independent variable. Whatever the case may be, it is expected that it will have some effect on the dependent variable. And what do I mean by dependent variable? That is the effect of manipulating or introducing independent variable. Like I've said earlier, student performance following Zoom activities is an example of dependent variable. Then what do I mean by continuous variable? They are usually metric, or they can be metric, or they can be in qualitative form, but they are measured in small units. When you say continuous variable, it means they take forever to count. For example, age can be a continuous variable in the sense that a 10-year-old boy can say, okay, I am 10 years, I am 10 months, 2 hours, 10 minutes, 5 seconds, 10 milliseconds, and so on like that. So it takes forever to count. But when we are talking about discrete variable, it's just a variable that the value is obtained by counting. You count directly. That one does not take forever to count, unlike the continuous variable. Example of this discrete variable is the money in your pocket. You can count how much exactly you have in your pocket. You cannot have, presently you cannot have, okay, you cannot have 10,536 kobo, you know, it's not like that. The money in your pocket, you can count exactly how much you have. The money in your bank account, you can say, okay, this is what I have in my bank account. However, age that I've used as an example of a continuous variable can, however, become a discrete variable, especially when you count the age in years or in months. Okay, I'm 10 years or I am 12 months. So age can also become a discrete variable. Now to intervening variable. When you say intervening variables, they are just abstract processes that are not directly observable. And it comes in between independent and dependent variable. For example, like the Zoom activities that I've used as an example for you in the dependent and independent variable. The language we speak can be an intervening variable. However, it is in between the Zoom activities and the outcome on student part, which is a dependent variable. Now to extraneous variables. They are just factors that may have effect on the dependent variable, which are not controlled. However, let me take you back to the lab setting, using it as an example of an experimental work. When you are carrying out a research in a lab, it is very possible that there could be interference along the line by noise. There could be changes in temperature. You know, you don't have control over this thing. You might be carrying out a research and rain can fall. However, this rain can actually affect the outcome of your research work. All this, you don't have control over it. They may be dangerous, and that is why you must put them into consideration whenever you are interpreting your research work. Experiments must have two types of experimental validity. We have internal validity and external validity. What do I mean by internal validity? Internal validity means how well you have carried out your research work. And when we are talking about external validity, it's talking about how well the results you have generated from your work can be transferred to the outside world. Going back to my example of a laboratory setting, in science, if you want to carry out, let's say, a new experiment, you want to test a new drug on human being, you first go to the lab. We use white rats or mice because they are very close to human beings systematically. So you have to carry out this experiment on them. How well you have carried out this experiment in the lab, that is the internal validity. Then the result you have generated from this experiment. Let's cite an example. Okay, you are carrying out a research on diabetes. You want to test a drug on diabetes. So the drug you have tested, let's say you have tested glucosamine, metformin, how well it has helped you in the laboratory by managing diabetes to some extent. How well can this same treatment goes to human being? That is talking about external validity. However, all this validity, they have some threats that can affect them. So what are the threats to external validity and internal validity? The threats to internal validity can be history, maturation, pre-testing, measuring instruments, statistical regression, differential selection of subjects. I would like to explain what I mean by those terms. The threat to internal validity, starting with history. What I mean by history is, okay, when you are carrying out a research, you are measuring quantities of drugs, for example. What will happen when you have measured the first one and the second one? There could be some specific events that can occur between each of these measurements. That is talking about history. And the maturation, especially when you're carrying out a long-term research work, anything can happen. Even in human beings, people can change, people can grow. All this will have effect on the outcome of your research. Then pre-testing, some people call it pre-testing, testing, and retesting. Let's say, okay, you have gone for a seminar, and part of the seminar is that you carry out a pre-test. They give you a pre-test before you start the seminar. Okay, something that might have happened after they have given you correction, they have given you information about the test you have carried out. They now say, okay, we have to carry out we have to do this pre-test again. For those of you that have done the first one, what will happen? Definitely, you will pass the pre-test more over and over again. So that is talking about pre-test. Then the measuring instruments. It depends on the instruments you have used during experiment. It can affect the outcome of your research. For example, okay, let's say you are carrying out a research, you are carrying out a research on observation. You want to observe some set of people. Probably during the course of the research, you have the course to change observers of this research. What will happen? It will affect the outcome of the research work. Then the next one is statistical regression. It's talking about when you select subjects on the basis of their extreme scores. That, okay, is it those people that has the highest scores that must be participant of this research, or those that had the lowest score that must pick to be participant of this research? However, sometimes the experiment itself could affect people having probably extreme scores or lower scores. So that is talking about statistical regression. If you look at this too, it can affect the outcome of your research. And differential selection of subjects. Okay, when you say, okay, you want to infer that the participants of this work will be those that participated from the beginning to the end of this research work. Those are the ones you're actually interested in. But don't forget, for example, let's say you want to carry out a research in ODL. about students from 100 level to 400 level. Those that have started the program together with you. Don't forget that some people might have dropped out of the study. And it is not as if, it could be as a result of the program itself. So if you are saying, okay, you want to exclude them, they might have some important things that they might want to contribute to the research. So that is talking about differential selection of subjects. Now the threat to external validity. We can have Orton effect. What do I mean by Orton effect? That is a kind of phenomenon in which individuals, they alter their behavior as in response to the fact that they know that they are being observed. For example, when you are doing your IT, or you are doing your teaching practice, you expect that your supervisors should come around. When they come around, what will happen? You present yourself so well. Probably you have not been dressing well, but the day you know that they will come around to come and check on you, so using your clinical experience as an example, you would dress well, you wear your shoe, you dress well. So it always results in positive changes. Then we can also have artificial experimental setting, like the laboratory setting now. The results you generate in the laboratory setting at times could be different from the real world itself. So that is talking about the external validity. Also, there could be selection bias. What do I mean by selection bias? If you want to carry out a good research, you select your participants randomly so that you don't have to be biased. But when you are biased, it will have effect on the general outcome of your research work. Another one is multiple treatment interference. Like the example I cited, that you're actually working on diabetes, you want to test, okay, which drug works better? You have given the animal metformin, you're also giving the animal glimepiride. Which one do you know works better? So with multiple treatment interference can affect the outcome of your research. So next now, we'll talk about types of, we talk about data collection. Next slide. Data collection instrument. What is data itself? You all know that we have to collect information when we are carrying out a research, and that is the essence of research. Data refers to a device that is used to collect information, and it is usually a fact-finding strategy. How will you carry out your data, your information collection? That is data collection instrument. What are the things you can use to collect your data? We have observation, we have questionnaire, and we have interview. Questionnaire has been the most commonly used by nurses especially. However, we'll talk about observation. Observation can be regarded as a process of looking out and recording the presence or absence of a particular trait or behavior of a person or group of persons. Before you start your project, make sure that you know how to interpret your observation. There are some variables that are important in observation. What are the types of observational variables? We have what we call descriptive variables. It's also known as low inference variables. In descriptive variables, there should be no inference or little inferences made, in the sense that you just have to observe something, then what you have observed, you write it down. Descriptive or low interference variables need little or no inference on the part of the observer. They generally yield reliable data. This is because if there are more than one observers, the level of their agreement in recording the same kind of behavior is expected to be high. Because you have not interfered, the responses you generate is of low inference. So when you have about 2 or more observers at the same time, you get a good and reliable data because none of you has interfered in the result, in the outcome of the observation. Then we also have high inference variable. For the high inference variable, an observer needs to give an inference before scoring the variable. It is not easy to collect reliable data on such variables because you have interfered as a researcher. You yourself, you have interfered in the outcome of the research. As the observer, when you are using high inference variables, it means you make inferences about what is observed. You observe someone, for example, let's say, okay, you have observed someone just banging on the keyboard of a computer. What do? You in high inference variable, you just assume that, okay, this individual is frustrated with this computer. That is your own inference, which might be true and might not be true. That is why it is said it is not easy to collect a reliable data on such variables. Another variable is evaluative variable in observation. In evaluative variable, more than inference is required on the side of the observer, because you need to make an evaluative judgment. For instance, a teacher is making an explanation or a description about a statistical concept. While you as an observer, what you do in evaluative variable is that you need to score and rate the quality of that explanation. Another example is the example I've cited for high inference. Okay, you see somebody banging on the keyboard of a computer, like I was banging before I could able to log in. Okay, you now infer that, okay, this person banging on the keyboard is actually frustrated. That means human being and computer, they are not friends. So that means you have make your own judgment from that behavior. That is the difference. Now, how do we carry out observation? What are the phases of observation? In carrying out observation, the first thing you do is to define the aims and objectives. In defining aims and objectives, you determine what you want to observe and why. For example, you can decide, okay, I want to observe how patients interact with their medical practitioners, their doctors, their nurses. That is your own aim. So you have to define what you actually want to observe. You want to observe, okay, how does bosses, how do they interact with their subordinates? That is your own aim and objective. After you have defined your aim and objective, the next thing you do is you select and define the attributes that you actually want to define. After that, you select your observation modes and you train your observers. In selecting observation modes, there are different modes that you can carry out observation. You can do note taking, like jotting. You can do video recording. You can do photographing and so on. But in selecting your observation mode, note taking is actually the best method. Administrative arrangement. In administrative arrangement, it involves developing questions and techniques. You have to be prepared. When you are entering an observation space, you have to have sound understanding of the type of information you are trying to learn. Then the next thing is carry out observation itself. In carrying out observation itself, you observe and take notes. You visit the place you want to get information from and only take photographs and audio recordings, especially when you are allowed. Don't go and take audio recordings or video recordings when you are not permitted. For example, when you are going to police SARS office, for example, immediately you want to enter their office, they will ask you, where is your phone? If you are doing yourself wrong, if you decide to hide the phone because you actually wanted to record an observation, if you are caught, you will be dealt with. So you only take photographs, audio recordings, and video recordings where you are allowed. If it is a formal observation, you need to quote some certain behaviors and actions so that you reduce the rate at which you judge. And the last thing in the phase of observation method is quantification of observation. Quantification of observation is by separating the differences between what you have observed and why what you have observed. What are the techniques for recording? What are the techniques for recording? In recording, there are different ways by which you can carry out your recording. The first one is duration recording. In duration recording, you involve collection of information on the length of a specific behavior by noting the time a behavior actually begins and when it ends. That is duration recording. There are frequency count recording. For frequency count recording, it involves recording the number of times that an individual engage in a behavior in a specific time period. Most times, frequency count recording is usually used when you want to reduce a behavior or when you want to increase the behavior. Another technique is interval recording. Interval recording involves observing whether a behavior occurs or not during a specified time period. And when we say another one is continuous observation. In continuous observation, it means that you carry out the observation continuously, non-stop, you do it continuously. Then the time sampling, it involves you watch participants for a specific amount of time, and you record whether or not the participants' behavior or activity took place. For example, when you watch something for a period of, let's say 2 hours at a time each day, and you do that for a month, that is time sampling. What are the types of observations? You can have the previous slide, please. You can have non-participant observation, and we can have participant observation. In participant observation is the one that the observer is either a member of the setting being observed or has joined the setting or group just for the purpose of carrying out that research. In this case, the observer is always the observed. They are always the observed. For example, your head of department, your principal or the teacher, when they are carrying out a research, they are part of the setting. So they use participant observation. And the other one is non-participant observation. Here, the observer is not a member of the setting or the group being observed. The observer visits the observed at different intervals. For example, when supervisors come around for your clinical posting, they are not part of the system. They are not part of the system. They are non-participants, but they have just come to observe you for that time period. That is non-participant observation. And that will take us to questionnaire. Questionnaire is another method of data collection. Questionnaire is another method of data collection. What is a questionnaire? A questionnaire is a set of printed or written questions with kinds of answers. They are designed for purpose of survey or statistical study. It is usually used to extract data from respondents. Questionnaire is not expensive. It's not an expensive way of data collection. Questionnaire is a carefully designed instrument for collecting information or data in relation to the specifications of the research question and hypothesis. We will discuss research question and hypothesis. Whatever your questionnaire is, it must not deviate from your research question. It must cover your research questions and your hypothesis. A questionnaire is made up of some components. What are the components of questionnaire? It's made up of the title. I know you have familiar. In the title is, okay, this is a questionnaire on social investigation. So you write what you are carrying out investigation on.
Apart from the title, the next thing is the introduction. That is when you introduce yourself. That is when you introduce yourself to your participants. Okay, I'm a person from LAUTECH Open and Distance Learning. You introduce yourself. That is the introduction. And you tell them why you are carrying out the research. Another component is the response instructor. You give them instructions. Okay, you are expected to take this part of the questions if it is appropriate. That is the response instruction. Then the next thing is biographical information. In biographical,
the questionnaire is a carefully designed instrument for collecting information or data in relation to the specifications of the research question and research hypothesis. I said, if you are designing a questionnaire, your questionnaire must carry the interest of your research question and your research hypothesis. What are the components of this questionnaire? It's made up of components such as the title. I know you are all familiar with a questionnaire. When you see a questionnaire, you see the title. Okay, this is the title of this research. It usually means the title of your research work. That is the title. Then you have the introduction. Introduction, you introduce yourself. My name is Adegoke Juliet. I'm 500 level student of ODL. I want to carry out a research on so. That is the introduction aspect. Then the next one is the response instruction. You give instruction on what to expect them to do. Is it for them to circle the option? Is it for them to mark the option? And so on. That is the response instruction. Then you have biographical information. From the biographical information, you collect data on probably their names, their age, place of work, level of education, and so on. Then you now move to your questions statement, whereby they will answer if it is question or if it is statement. They will either pick true or false or so on. Rather agree, strongly agree, or so, depending on what you have used. Then you have a section for return instruction and gratitude. For you as a student, it is important that you have a letter of reference from an appropriate authority, which may accompany your questionnaire. By the time you come in 500 level first semester, after you have carried out your proposal defense, the school management will give you a cover-up letter, which will introduce you to your participants or to institutions where you want to carry out your research. And this will help you to gain cooperation of your respondents. What are the types of questionnaire? What are the types of questionnaire? For the type of questionnaire, you can have types of questionnaire. You can have
We can hear you before, but we can't hear you again. Can you please check your mic and continue?
for the types of questionnaire, you can have different types of questionnaire. You can have, the types of question in a questionnaire, not types of questionnaire. You can have structured or fixed response questionnaire. Can you hear me now? structured or fixed response questionnaire. Here, the respondent they are restricted to some response options. A question is asked or a statement is made, and the respondent has to choose from the available alternatives. In fixed response questionnaire, it is usually used to get feedback on probably a product or a service. You can also have another type of question, that is open-ended question or open-ended question. This allows your target audience to voice out their feelings openly. And it is usually used during interview to ask questions. It is used during interview to ask questions about opinions, about views, or about an aspect. You can ask, okay, how do you think we can reduce this transmission of COVID-19? That is an open-ended question. You have different responses from this question. How do you know if your questionnaire is valid? The only way you can know if your questionnaire is valid is if you subject it to expert validation. In this method, you have to make copies of your questionnaire, then you give it to panels of experts in that field. You will also write a covering letter to this expert. You tell them what you actually want to carry out from the research. What do you want to achieve from that research? That is how you can carry out a validity of your research questionnaire. Or else, if your questionnaire is not valid, the reason why you have to give them a covering letter on what you want to carry out is to know that if your questions has covered all aspects that is necessary to cover. Then you carry out a pilot study. You test your questionnaire, and this involves you administering the questionnaire on a very small sample of those whom you want to use for your final study. For example, you want to work on nurses. You can carry out a trial study or a pilot study by, okay, you want to use 500 people. You can decide to pick a smaller portion of the population, and you administer this questionnaire. You check if the responses they will receive. It becomes more reliable when other questionnaires yield almost the same response. And that is it about validation and pilot studying. We now move to interview. Interview is another form of data collection. Sorry, how do you administer your questionnaire? You can administer your questionnaire in different ways. You can administer your questionnaire by mail. Either you send it through email, and you can do personal administration with on-the-spot collection. You give the individual the questionnaire and you wait and collect the questionnaire. Or you can do personal delivery and you collect after some time. Some people will come and drop questionnaires with you and they will tell you, I will come back for it. That is how you administer questionnaire. Then the next thing is interview. Interview is another way of data collection too. It is a method, it involves eliciting information through some verbal interaction between respondent and the researcher. Interview is an appropriate way to collect depth information on people's opinion, people's thoughts, their experiences, or their feelings. The questions used in interview are usually open-ended questions so that you get in-depth information of what you are carrying out. There are some phases of interview. How do you carry out an interview? It includes preparatory phase, rapport phase, question and answer phase, and finally recording phase. What's happened in each of these phases? In the preparatory phase, you identify your question. You anticipate what can be their own question. Then you review the resume of the person you actually want to interview. Depending on the resume, it will determine what kind of question to expect. Then you identify the length of time that you needed to carry out the interview. Then at the rapport phase, You get yourself acquainted to the individual. You need to explain procedure that will be followed, and you allow opportunities for their own questions too. Then in the question and answer phase, you have to gather information, you use appropriate questions, you monitor verbal and non-verbal responses, you take notes, and you thank the candidate. And the recording phase, you have to record your own impression of the interview. There are basically two types of interview. You can have face-to-face interview and you can have telephone interview, depending on which one you want to carry on. And that will take us to the next part, which is research question. What is a research question? A research question is an answerable inquiry into a specific concern or issue. It is the initial step in a research project. By initial step, it means that after you have had an idea of what you want to study, the question is the first active step in research project. You want to carry out a research on something, a question will come to your mind. It is that question that is the initial step after you have had an idea of what you want to study. Research question is a question around which you center your research project. And it is what everything in a research project is built on. Without a research question, you cannot have an hypothesis. And without the hypothesis, you wouldn't know how to study what you are interested in. A research question forms the base of where you are going. So we have to write a good research question. You know, if a foundation of a house is built on something shifty, what will happen? Like when the house is built on a sand, then everything that will be following will be about correcting the initial error that has happened. So that is why you need to have a good research question. A good research question should be focused, it should be concise, and must be a bit complex. What do I mean by a bit complex? It should not be a question that you just answer by yes or no. It should require you to synthesize and analyze ideas. That makes it to be a bit complex. If you go to your course material, you see different examples of a research question. The research question serves two purposes. It helps to determine where and what kind of research the writer will be looking for. It also helps to identify the specific objectives or what the paper will address. Many people usually make mistake of putting research question and research objective together. They are two different things entirely. A research question is different from a research objective. A research objective is the purpose or the intended task plan to be achieved in a research work. While the research question is the process of stating the problem of the research, which will give you deep insight about the research to be embarked upon. And that will take us to, how do you write a good research question? To write a good research question, you must specify what is your specific concern or issue. You must state it. Then you now decide, what do you want to know about this problem itself? Okay, the problem you want to look at is COVID-19. So what is it that you want to know about COVID-19? There are many things about COVID-19. What is it that you want to know about this COVID-19? Then you now turn what you want to know into specific concern, and the specific concern into question. You form questions from what you are actually interested in knowing. And you ensure that the questions you have asked can be answerable. Then you check to make sure that the questions is not too broad and not too narrow, which means it should be a bit complex. That is it about writing a good research question. If you go back to your notes, you see different examples of research question. And that will take us to research hypothesis. Don't forget, I said without a research question, you don't have a research hypothesis. I've come across many students in their project. They'll tell you because they have a research question, they don't need an hypothesis. That is all lies. So what is a research hypothesis? A research hypothesis is a statement that is created by the researcher when they speculate upon the outcome of a research. A research hypothesis is just like a prediction, is a tentative prediction about what will be the relationship between two or more variables. A research hypothesis is usually predictive in nature, while a research question is inquisitive. You predict in hypothesis. It is based such that it is based on the differences between two groups of variables. You compare the relationship between these variables. What is the precursor to a research hypothesis? The precursor to hypothesis is research problem, and it is usually framed as a question. It might ask what or why something is happening. To write an hypothesis, your hypothesis must be written in a clear and concise language. It must be clear. And your hypothesis must have both independent and independent variable. When we started, we have talked about independent and independent variable. You must compare relationship and predict what will happen between the two. So your hypothesis must have an independent and dependent variable. And you must be able to prove or disprove your statement. Like I've said, is a prediction. And you make a prediction or speculate on an outcome. Your hypothesis must be practicable. There are different types of hypotheses. The first one is we have null hypothesis, we have alternative hypothesis, we have directional, we have non-directional hypothesis, we can have causal hypothesis. What do I mean by null hypothesis? I know you have heard or you have come across researches where they say, okay, there will be no significant difference in the relationship between so variable and another variable. That is a null hypothesis. A null hypothesis says that there will be no statistical significance between two variables in the hypothesis. And it is usually the hypothesis the researcher will try to disprove or discredit. The opposite of this null hypothesis is the alternate hypothesis. And it will state that there will be significant relationship, just go straight, there will be significant relationship between two or more variables. That is null hypothesis. What is directional hypothesis? There are those that can predict direction. From the word directional, they can predict direction. For example, what is the effect of one variable on the other will bring either positive or negative effect. So they give direction. And it is usually used, this directional hypothesis is usually used when a previous research has suggested that a finding of the study will go in a particular direction. That is when you use a directional hypothesis. But for non-directional hypothesis, they do not specify the expected direction of an effect or a relationship. The last one is the causal hypothesis. The causal hypothesis, from the word causa, it is the one that will suggest that a cause and effect relationship exists between two or more variables. That is it about types of hypothesis. The next one will be, what is hypothesis testing? By the time you have, but when you get to your analysis, when you get to the stage whereby you have to analyze your results, you have to give out your data to an analyst to carry out your hypothesis testing for you. It is just about testing to see whether the stated hypothesis is acceptable or not. In hypothesis testing, you have to gather as much data as you can so that you can prove your hypothesis one way or the other. There are different steps involved in hypothesis testing. The first thing you do is you write out the hypothesis. If you are carrying out, if you want to give your analyst your hypothesis for you, your data for you to test, you must write out your hypothesis and give to the analyst. Then you create an analysis plan. The analyst will analyze your data for you and will give you the interpretation of the data based on the information you have given your analyst. There are some errors that can take place during hypothesis testing. We can have type 1 error. We can have type 2 error. Type 1 error is a type of error that occurs when null hypothesis is rejected when it is true. It occurs when null hypothesis is tested, when null hypothesis is rejected when it is true. That is when you have type 1 error. Let me give you an example of what I mean by this. The null hypothesis is that a person is innocent when somebody is innocent. While the alternative hypothesis is that the person is guilty, just like word and opposite. But type 1 error will occur when the person is not found innocent. Don't forget, I said this person is innocent. But when the person is not found innocent and the person is sent to jail, despite the fact that the person is innocent, it means you have committed type 1 error. So I want you to relate it back to research work. And how can you reduce this type of error? To minimize this error, you ensure that you minimize the significance level of the hypothesis. Your significance level of hypothesis can be minimized to 1%. Usually we use 0.05 as your significance level. The type 2 error is usually committed when we fail to believe a true condition. It occurs when you reject the alternative hypothesis when it is true, or when the null hypothesis is actually false and you accept it to be true. Don't mix it together. Type 1 and type 2 error. In type 1 error, I said it happens when the null hypothesis is rejected, but when it is true. For the type 2 error, it is usually committed when you fail to believe a true condition. That is, when you reject the alternative hypothesis when it is true, and or when the null hypothesis is actually false and you accept it to be true. So to avoid this type of the type 2 error, what do? You ensure that your sample size is large enough to detect a practical difference. There are many people that has issues with sample size, and that will take us to sample size determination. I hope you are all with your pen and biro, because we are going to carry out calculation in this sample size testing. Are you with your pen? If you are with your pen, just go to your chat room and say yes. Okay. I can see responses. Okay. I said that will take us to sample size determination. Talking about sample size determination, there are different methods that you can use to select your sample. Sample size determination itself is an act of choosing the number of observation or replicate to include in a statistical sample. In many researches, when people come for research defense, there are always issues with how did you get your sample size? And that is why I want to clear this issue with you. There are different ways that you can select your sample size. But the commonest ways of selecting sample size in nursing, the first one is Taro-Yameni's formula. I know you have heard about this on several occasions. Many people use Taro-Yameni's formula. And you only use Taro-Yameni's formula when your population is known. When your population is known, that is the only time you can use Taro-Yameni's formula. Okay, you want to work on the number of people that has COVID-19. Thank God for NCDC. They have given us statistics. We have everyday daily statistics. You know the exact number. That is when you can use Taro Yameni. But when you don't know the exact number of the population involved, you can use either Tom's rule, you can use Unwana's rule, you can use Arauye's rule. What does this mean? In Tom's rule means what is universally acceptable by all researchers. It means you use 30% of the population involved. And according to Unwana, he says you should use 40% of the population involved. And according to Arauye, he said we should use 50% of the population involved. Again, Tom's rule says we should use 30% of population involved. Unwana says 40% of the population involved. And Arauye says 50% of the population involved. I'll teach you how to calculate this. Using Taro Yameni's formula, on your screen is the simplified formula for Taro Yameni. And it's stated as small n is equals to capital N all over 1 plus capital N into bracket E squared. Only E is squared. And what are these values? The small n is the sample size you want to calculate, you are looking for. Is that taken? The capital N is your population that you are aware of. You know, I said you only use Taro Yameni's formula when you know the exact population. And E, the small letter E, some people use it as small letter E, some people can use different letters, but what is important that the small letter E is the acceptable sampling error, which is the significance. We use 0.05 in nursing. Is that taken? 0.05 as E value in nursing, error of significance. So if you are calculating, okay, I want you to carry out a class work. That's why I said, are you with your pen? Using Taro Yameni's formula, I want you to calculate the sample size of a total population of 2,000 participants. Using Taro Yameni's formula, calculate the sample size if the total population is 2,000. That means it will be 2,000 all over 1 plus 2,000 into bracket 0.05 squared. And 0.05 squared is equals to 0.0025. So carry out your calculation and tell us the answer. Can I have answer from the house? 2,000. The total population is 2,000. Somebody said I should come again. The total population is 2,000. And you want to carry out your sample size. To carry out your sample size, it will be 2,000 all over 1 plus 2,000 into bracket 0.05 squared. When you carry out this calculation, it should give you 333. That will be your sample size that you will use. That means you use 333 people. Yes, I've seen people doing the calculation. You are right. Adebite, you are right. Yes. So we have 333 samples to use for that research work. That is it about Taro Yameni's formula. Then let's go to Tom's rule. Like I've said, in Tom's rule, it also has a formula. Tom's rule, I said, is 30% of the population. Don't forget that. To calculate the sample size, the formula is displayed on your screen. Is Z squared PQ all over E squared, where Z is the acceptable interval. And Z is acceptable interval. It is usually 1.96 or 2. In nursing, we usually use 1.96. 1.96 is very common, as Z squared is a constant. Then the P is the 30% of the Tom's rule. This formula cuts across the general terms rule, the Huwana, and the Rauye. So here for terms rule, the P will be 30%. If it is for Huwana, it will be 40%. And if it is for Arauye, it will be 50%. Is that taken? So Z is the acceptable interval, usually 1.96, and P is 30% if you are using terms rule. Then that 30%, you have to convert it to a decimal point. That will give us 0.3. And your Q, that small q, is equals to 1 minus P. 1 minus P. If you are using terms rule, it will be 1 minus 0.3. And that will give you 0.7. If you are using Iwana, it will be 1 minus 0.4. And that will give you 0.6. So then the small letter E is the level of significance, which I said is 0.05. So that is it about terms rule. So depending on which one you are using, examiners can ask you, which one have you used? Is it terms rule of 30%? Is it according to Unwana? Is it according to Arauye? There are different methods of sample size determination, but the commonest ones we use in nursing are the ones I just discussed with you. And finally, today we'll discuss scales of measurement. Scales of measurement. What is measurement itself? Measurement is the process of applying numbers to objects according to set of rules. You apply numbers to objects according to set of rules. There should be a rules that will follow the numbering. And in research, measurement. I'll take it back. Scales of measurement. What is measurement itself? Measurement is the process of applying numbers to objects according to set of rules. There should be set of rules. So you now apply numbers to the objects according to, it is usually the analysts that usually make use of all these scales of measurement. And there are 4 scales of measurement. We have the nominal scale, we have the ordinal scale, we have the interval scales, and we have the ratio scales. The nominal scales, in nominal scales, what happens? You assign numbers to objects, whereas different numbers indicate different objects. But these numbers, the numbers does not have real meaning, other than they differentiate them. Example is this. Okay, you want to carry out a research. Under gender as your variable, you assign 1 to male, and you assign 2 to female. This does not mean, when I say in nominal scale, numbers have no real meaning. This means that for when you assign 2 to female, does not mean that female are superior to men. So it's just assigning number just to differentiate them. That when you see 1, 1 is male, and when you see 2, it is female. Another example is football players. I know on their jersey, they usually have different numbers. I'm not a football fan, so I don't really know the numbers. But I know they have different numbers at the back of their jersey. It does not mean that football number 1 is superior to number 2. It's just to differentiate them. That this is number 6, this is number 5. It's just to differentiate them. That is nominal scale. In ordinal scale, for ordinal scale, you assign numbers to objects, but the numbers have meaningful order. For example, in election, with the outcome of election result, we should have first, we should have second, and we should have third. You know, all these numbers have meaning when it comes to election issues. The first is different from the second. Definitely the first is the first, and the second is the second. Also, when you are playing games, it's either you are the first or the second. So we use ordinal scales for numbering of objects like this. Then for interval scale, in interval scales, numbers have order, but there are also equal intervals between these adjacent categories. Let me explain what I mean. Using temperature as an example. When you are having temperature of 35 degrees centigrade, and you have temperature of 36 degrees Celsius, you know, you have just 1 degree in between. Also, when you have 40 degree and when you have 41 degree, the 1 degree between 35 and 36 is the same 1 degree between 40 and 41. So, which means the numbers, they have order and they have meaning, and they also have equal intervals between the categories. And lastly, to the ratio. To the ratio scale, it means there are differences in numbers which are meaningful, plus ratio. In ratio scale, when you have 0, it means absence or absence of that thing, or that thing does not exist. That is the difference between the scales of measurement. This is where we will stop. Thank you all for your time and attention. Thank you so much. I believe I've been able to deal with NSC 408 as you have been taught in class. Thank you so much.
Thank you, facilitator. Now, if you have questions, kindly raise your hands so that we can entertain like 4 questions. Otobo, Onome, your question. Otobo, Onome. Otobo, Onome. Didant, your question. Okay. Kasim Alimat, your question. Since you don't have question, I don't know why you people raise your hand. Okay. Rita, Dada, your question.
Hello? Hello?
Hello, ask your question.
Hello, can you hear me?
We can hear you. Ask your
Okay,
question.
thank you. Good morning.
Good morning.
Okay. All right. Thank you, sir. I need more explanation on sample size determination. My network was fluctuating. I didn't get you that when you were explaining it. And there are some figures that are in our handout, which was different from what you explained to us, different from the calculation you give us. Should we disregard the one in our handout and use the one you gave us? And then the names, the Tarawi, explanation there, please.
Okay. Thank you for that question. Can I speak on?
You can answer.
Okay. You said you missed it at the sample size determination. Like I told you, there are different methods that we can use in determining our sample. But specifically, the one we use in nursing are the ones I discussed with you. I'm not saying you should disregard them, but the ones you are going to use for your project are the ones I just discussed with you. The first one I discussed was Taro Yameni, and it has a formula of small n. If you go back to the slide, you will see the formula. Small n, which is equal to capital N, all over 1 plus capital N into bracket E squared. That is Taro Yameni. And we have other formulas too. We have the Tom's rule, we have the Unwana, we have the Araoye. So I don't know which, is it the meaning of those letters that you want me to explain to you? For the capital, for the small n, that is what you are looking for. But for the capital N, That is the total population you are aware of, that you know. So don't forget, if you want to use Taro-Yameni's formula, one criteria why you want to use Taro-Yameni's formula is because you actually know the total number of the population you are dealing with. If you don't know the total number of population, you either use Tom's rule, Unwana, or Arauye. So most times, when you know, to know the total number of population, there are even some people that will have to carry out statistics of patients for the past 3 to 6 months. It is acceptable to be the total number of population, especially in clinical areas, but you must reference them to give you the total number of population that you are aware of. So when you input those figures, the E is the level of significance, which is 0.5. So when you input those figures, you'll be able to get the actual number of your sample size.
Thank you. Please,
and for the top, I said.
Please, can you explain more on type 1 and type 2 error?
Okay. For type 1 error, for those errors, there are errors that you can make when you are doing your hypothesis testing, like I've mentioned to them. So most times when analysts when they make hypothesis testing, they can make any of these errors. Okay, can you hear me? Can you hear me now? So type 1 error is the kind of error that you make when a null hypothesis is rejected, but they are true. Like the example I cited, somebody is not guilty. You know this person is not guilty. And at the end of the day, you are saying the person is guilty when you know that the person is not guilty. So that is type 1 error. Then for the type 2 error, that is when you reject the hypothesis, even if the null hypothesis is not correct. There are some researches that you carry out. You know that what you have gotten is not correct, and you are still, when the null hypothesis that you have stated is not correct, and you are still, it is correct, and you are still rejecting it. That is type 2 error. Is that okay? Somebody said
clarification
hello?
on Tom's rule.
Clarification on Tom's rule. For
Yes,
Tom's
more
rule, I've told
clarification.
you the formula. If you go back to the slide, you see the formula. It is, for Tom's rule, it means what is acceptable by all researchers. And it has a formula. When you know your sample size, it has a formula. That is Z square, PQ over D square. And for Tom's rule, it means use 30% of your population. For Unwana, you use 40% of your population. And for Arauye, you use 50% of the population. The Z, I said, is an acceptable interval, which is usually 1.96. That is what you use at your level now, 1.96. And the P, if you are using Tom's rule, you use 30%, don't forget. And that will be 0.3. If you are using Unwana, it will be 0.4. That your P value will be 0.4. And your Q will be 1 minus P. This is the formula. Q is 1 minus P. So if you are using Tom's rule, your Q will be 1 minus 0.3, and that will give you 0.7. Then your E is the level of significance, which is 0.5. You can come across different literatures. The E, some people can write D, depending on their interpretation. So it can be E, it can be D, depending on the school of thought. But when you input your values, you'll be able to get your sample size. Any other question?
Olajumoke, your question, please.
Good afternoon, ma.
Good day, ma.
Yes, sir. My question is actually on the. My question is where we ended on the measurement scales. Can you please explain more on the ratio scale, ma? I didn't get it.
Okay.
Thank you,
On
ma.
the ratio scale, were you following from the onset? Where I was explaining from the nominal scale.
I was following, ma.
Are you following?
Yes, ma.
Okay. I said that in the nominal scale, you are saying numbers, but this number does not have meaning.
Yes, ma.
Did you get that?
Yes, ma.
Then on the ordinal scale, these numbers, they have meaning.
Yes, ma.
But for the ratio scale, the number also has meaning, just like the ordinal and interval scale.
Okay.
But for the ratio, it allows you as a researcher to compare the intervals or differences. When you have a 0 point, it means that that thing does not exist at all. Do you get that? Hello, do you get that?
You can continue.
Okay, so most times the ratio scale always has properties of an interval variables, and they have a clear definition of. They usually use ratio from the word ratio. It's usually 0.0 something. So when the variable equals 0.0, that means there is none of that variable.
Obiagba, your
All these
question.
scales are usually used by.
Thank you very much, ma, for the wonderful lecture. Ma, please, can you throw more light on validation and pilot testing? Thank you, ma.
Of which of the instruments? Of which instruments?
Of questionnaire, ma.
Validation of which instrument? Are you talking about questionnaire?
Yes, ma.
Okay, if you are talking about questionnaire, immediately you be the one to draft the questionnaire yourself. And I said when you want to draft your questionnaire, you have to consider some factors. You have to consider your research question. You have to consider your hypothesis. There are some key variables in your research work that you must include in your questionnaire. So when you have done this, you design your questionnaire. It's always a self-designed questionnaire. After you have done it, to make it valid, before you give out your questionnaire, you have to give it to experts in the field. Probably you can give it to supervisors, you can give it to consultants. They will go through it. And when you are giving it to them, when you are giving them your questionnaire, you must also give them the variables you are considering, the title of your research. What are your research questions? What are your research hypotheses? After which they will go through all this. It is when you can give it to more than one expert. When you give it to more than one expert, you can make corrections. It makes your questionnaire more valid. And on the issue of reliability of your questionnaire, you must carry out a pilot study. And a pilot study is just a minute research work. Let's say you want to use 100 subjects when you have calculated your sample size. You want to use 100 subjects. You can decide that, okay, I'll take 10 people. It might not even be the same place that you are carrying out your research. Let's say you want to carry out a research in teaching hospital, probably use university teaching hospital, Ibadan. You can look around, okay, and look for another. Okay, let's say you carry out a research in university teaching hospital. So probably you are using surgical nurses. And you know that, okay, you have about 100 of them. You can just pick about 10.
James Mustafa, your question. Mustafa James, your question. Adekunle, your question. Ade, your question.
Hello, ma.
Go ahead and ask your question.
Thank you, sir. On the types of measurement scale, I want her to throw more light on ordinal scale.
Your audio is cracking, so we can't hear you clearly.
I heard that she said she wants me to throw more light on ordinal scale.
Okay.
Yes.
I said it's ordinal scale. You assign numbers.
Okay, ma.
To objects. So, but the numbers that you have assigned has meaning in the sense that they follow a meaning order, just like the word ordinal. They follow an order. Okay. That is why where I cited example of position. In exam, you can be first position, you can be second position. You know, there's difference. It has meaning when you are first and when you are second. It has different meaning. So that is what makes, that is when we use ordinal. So I cited example of election too. The first position in an election is different from the second position in an election. Is that taken?
Yes.
So depending on what you are working on, that is when your statistician will know what scale of measurement to use. It's just for you to have an idea. It's good for you to have an idea so that you know what you bring out from the research to guide your statistician. That is the essence. Any other question?
Ade, your question. Ade. Tijani, your question. Fisayo, your question.
Thank you very much for the class, ma. I want to make a clarification on that Taro Yamine's rule. On the formula, you said small n equal to the big N, capital letter N over 1 plus N. I want to show, is it big N plus bracket is square or just bracket is square? Because on this thing, I think there's a plus there after the big N. I don't know. Maybe that's not my question.
The capital N, the capital is not plus, is asterisk.
Okay.
It's asterisk. It's
okay.
Multiplication.
Okay. Thank you, ma'am.
That is asterisk. It's not plus.
Thank you very much.
For those of you saying the question is not clear, please go back and sit down and take your time to carry out this calculation. I've given you example. When I said when you have about population of 2,000, using Taro Yameni's formula, you should have your sample size about 333. And I know many of you calculated it and got it right.
Ambode, your question.
Good afternoon, ma. Okay, still on the sample size determination. So in our handouts, there are some calculation. It's not that clear. It's not correspondent with what you just taught us now. So I want to clarify that should we go along with the one you just taught us, or we should go with the one in our handouts?
I'm going there now.
I've answered that question. I've answered what the question you just asked. When I said sample size determination, there are different methods you can use. But the commonest and the most acceptable one are just the one I just discussed.
Okay. Read down your question. Fatoba. I think you can reach your facilitator after the class. So this is how far we can go about the question for today. So the facilitator, do you have anything to say before we end the class?
Thank you so much, coordinator. I don't want to employ the learners. I wish them all the best in their exam. And concerning their research work, many of them have not started anything. They should try and do whatever is required of them. They have been assigned supervisors, and it is expected that you contact your supervisors with your topics. When your supervisor has approved your topic, you can go ahead and write your chapter 1 to 3. Because by the time you come to school in 500 level 4 semester, you should be prepared for your proposal defense. I wish you all the best. Thank you so much.
Then I can see some of you are asking, how do you get to your facilitator? She's not new to you. She has been taking you since your 200 level. So by now, you should have her details. So try to reach her and ask her any question. Thank you, and God bless you.